Okay, so first of all, what observations do you have based on this lovely multiplication pattern that we've got going on here? We've taken x plus y, and first of all, anything to the 0 power is 1, right? But then we decided to take it to the first power, which is good old x plus y. When we square it, boiling it out, you first times first, outsides insides last, we get x squared plus 2x plus y squared. Here's our x plus y cubed. If we multiply all that out, x plus y to the fourth, x plus y to the fifth. So what observations do you have, or what things do you notice about this? Kind of forming a triangle, isn't it? Okay, a wide triangle. What else? And the triangle that you're thinking of, are you thinking of Pascal's triangle? Good. Okay. You're seeing the coefficients, right? The coefficients aren't obvious here, but we have a 1. And then the coefficients of our x to the first, x plus y to the first are 1 and 1. Our coefficients of our squared term are 1, 2, and 1. Coefficients of our third term, to the third power, are 1, 3, 3, and 1. Then we get 1, 4, 6, 4, 1. And then in this x plus y to the fifth power, we have a 1, 5, 10, 10, 5, 1. Called Pascal's triangle. In honor of Blaise Pascal. Okay. So, what's the relationship between the previous row and the next row? Once we get beyond these first two rows. The sum, good. 1 and 1 gets me 2. We always have a 1 on the outside, right? 1 and 1 gets me 2. 1 and 2 gets 3. 1 and 3 makes 4. 3 and 3 makes 6. And 3 and 1 makes 4. Okay? So if we have Pascal's triangle available to us, or create Pascal's triangle, we can come up with the pattern for the coefficients, can't we? Okay? When something was to the 0 power, a binomial to the 0 power, how many terms did it have? How many terms here? 1. If something's to the first power, how many terms does it have? If something is to the second power, how many terms? If something's to the third power, okay, so it's always going to have n. If it's x plus y to the nth power, how many terms will it have? Yep. Okay. And what do you notice about the exponents of the variables? They're mirror images of each other, aren't they? Okay. And they always add up to the power of that term, right? Okay. The third power, 2 plus 1 is 3, 1 plus 2 is 3, and 3. Okay. 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, 4. Okay. So lots of great observations that we can make about these. So The binomial theorem says that if you're expanding binomial, then you can use a formula. Okay? That formula says take a combination, NCR, to get your coefficients. And then your first term will have your nth power to begin with. The second term will be one less than that nth power, and your second term will have a first power. The next term's power decreases by 1 for the first variable, increases by 1 for the second, and so on. And the combination of n with r is going to be denoted as n factorial over n minus r factorial times r factorial. And we often use this symbolism to replace this for the binomial coefficients. So lots of stuff going on here. Okay, everybody good? Have it all written down? Not yet? Okay, so here we go. So they want us to find the binomial coefficients using this symbolism. While you're writing that down, I'm going to bring up my calculator. Okay, so 10CR means that we're going to take, here's our n, here's our r, 10 factorial divided by n minus r factorial times r factorial. Okay, so when we do this on the calculator, your calculator, remember, has in the math section, make that go away. Okay, In the math section over by probability, we have our factorial button. So we'll use that first to make sure you understand what we're doing here. And then notice that we also have a combination button. So we're going to use that. So 10 factorial, put in your 10 first, go to math, over to probability, choose number 4. Okay. We're going to use that button in just a second. Okay. Okay. And you can also simplify this yourself by saying, well, this is going to be 10 factorial over 5 factorial times 5 factorial. And 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial and 5 times 4 times 3 times 2 times 1. So if you didn't have a calculator, we can still do this. 5 times 2 is 10. 4 is an 8. 3 is in 6 or 9. So 3 times 2 times 7 times 6 is what our result will be. Okay? We have a factorial button, so 10 factorial divided by, put it down before I try to divide. And we want a 5 factorial times a 5 factorial. So we need to put a parenthesis here and say 5 factorial. Oops, didn't hit. Times 5 factorial again. If we're multiplying them, yeah, the denominator will need to be in parentheses. That's what we're going to do next. I want to show you that they're the same thing. Absolutely. So this should be 252 to begin with, okay? And then there's an NCR button on your calculator. So the NCR button says start with your 10, then get the NCR button, and then type a 5. So 10, math, probability, option 3, and then we want a 5. All right, those with the Casios, did you figure it out? You okay with finding those? Okay. All right, so far so good? Okay. So let's quickly do 8C2, 8 math, probability, 3, and then a 2. She get 28. Okay. 12C4. Just different notation. Okay. You have a newer calculator than the one that I'm emulating. Exactly. Tell me what you're putting in. Well, to show your work, you'd want to say that this is 12 factorial divided by, yeah, and then use the button. Okay. Yep. The n is the 8, and the r is the 2. Just a different notation for binomial theorem expansion. Okay. So lastly, here we would say 12 factorial divided by 12 minus 8 is 4 factorial and 8 factorial. So we should get the same result. And that's okay because it has that repeating pattern where you're going to get those coefficients that will repeat. On number 3, yep, you have to take your 12 minus 4 and then your 4. Okay, that's how the combination is defined. So far, so good? All right. Next slide. So we just talked about Pascal's triangle. Everybody's okay with generating it? What would we get for our next line? 15, 20, 15, 6, and then always a 1 at the end. Okay, so we could continue on. So this is the 0th row, the 1st, the 2nd, the 3rd, the 4th, the 5th, the 6th. Okay. All right. Oops, wrong one. So now they want us to find the expansion of x plus 2 to the 4th without taking x plus 2 times x plus 2 times x plus 2 times x plus 2. They want us to use the binomial theorem. So the binomial expansion of x plus 2 to the 4th says to find the sum as r goes from 0 to 4 of the coefficient times x to the 4 minus r and 2 to the r times 2 to the r. Okay. So now we're going to use our summation. We start out with r0, right? Okay, so this means that we're going to take a 4c0 times x to the 4 minus 0 times 2 to the 0. That's our first term. Our second term, when r is 1, will be 4c1 x to the 4 minus 1, 2 to the 1. R will be 2, so we're going to do a 4c2 x to the second, 2 to the second, for C3, x to the first, 2 to the third, and finally for C4, x to the 0, 2 to the 4. Okay. So simplifying this, 4C0 means take 4 factorial, divide it by 4 minus 4 times 0 factorial, and 0 factorial is 1, so we're going to get a 1 there, which we knew, right? Okay, and then x to the 4th and 2 to the 0 is 1, so 1x to the 4th. Okay. Mm-hmm. The power of the remaining, yep, goes up 1. Yep. Mm-hmm. Sure. Mm-hmm. Yes. On the bottom here, that's what this is defined as. When I take, when I find the combination, I take the factorial of n, and then I take n minus r factorial, and then r factorial. Okay. Now we're ready to do the next one. So 4c1 is going to be 4 factorial again over 4 minus 1, 3 factorial, times 1 factorial. And then x to the third times 2 to the first. So 4 factorial over 3 factorial times 1 factorial is going to get us 4. Okay. 4 times 2 is 8, x cubed. Next one. 4c2 is 4 factorial over 4 minus 2, 2 factorial, times 2 factorial. X squared times 4. 4 factorial over 2 factorial is 4 times 3, and 4 times 3 over 2 is going to get us a 6. And 6 times 4 is 24. Next one. So we have a 4c3. So 4 factorial over 4 minus 1 factorial times 3 factorial. X to the first times 2 cubed. So we will get 8 times 4 factorial over 3 factorial is again a 4. So 4 times 8. And our last term, 4c4, is going to be 4 factorial over 4 minus 4 is 0 times the r again, factorial. X to the 0 is gone, and 2 to the 4th. So we'll have a 1 there, turns into a 16. A lot of symbolism. A lot of the stuff that we've been working with, though. Okay? Ready to see another one? Ready to see it? Okay. Summation, right? As r goes from 0 to 4, right? Of 3x to the what? I forgot this. And then it's going to be 3x to the 4 minus r and 2 to the r. Oops. Okay. Not forget our coefficients. Yep. And it's going to be NCR, depending on what that's going to be. Okay. And then 3x n minus r, and then negative y to the r. Okay. So NCR, we have when r is 0, 4c0, 3x to the 4 minus 0, negative y to the 0 for our first term. Second term, 4c1, 3x to the third, negative y to the first. For C2, 3x to the second this time, negative y to the second, for C3, 3x cubed, negative, oops, sorry, 3x to the first, negative y is to the third. And then for C4, 3x to the 0, negative y to the fourth. God bless you. Okay? So nothing here. This is going to be a 1, and 3x to the fourth is going to be 3 times 3 is 9 times 3 is 27 times 3 is x to the fourth, right? Okay. This is going to be a 4 factorial over 4 minus 1 times 1 factorial. So 4 times 3 times 2 times 1 over 3 times 2 times 1 is going to get us a 4. And then we have 8 times a 3x cubed, 27x cubed, right? Times a negative y to the first is a negative y. What's 4 times 27? 108. Okay. Next one. 4c2 is 4 factorial over 4 minus 2, 2 factorial, r factorial again, 2 factorial. 4 times 3 times 2 times 1 over 2 times 1, 2 times 1. Do the 6 there. 3 squared. And negative y squared is going to be y squared. So 6 times 9, 54. X squared, y squared. Okay, did not give myself enough space on these. This next one, 4c3. So 4 factorial over 3 factorial is 4. 4 times 3 is going to be a 12. But it's going to be negative here. It was, I should have showed another line. Because this was, where's my y squared at? This was going to be 4 factorial over 2 factorial. So the 2 factorials cancel. We just have a 4 times a 3, which is 12. 12 divided by 2 is 6. Okay, so this guy reduced to 6. And 6 times 9 is because the y is just, it's just y that's being, a negative y that's being taken to the power. So this gives you the coefficient, and then the extra numbers being multiplied by the coefficients are coming from the 3x. Okay. Finally, this last one, 4 factorial over 1 factorial times 4 factorial is going to get us a 1. X's are gone, and a negative y to the fourth is going to get you a positive y to the fourth. Okay. We're not going to do very many. They take a long time. Okay? How do we find the coefficient of x to the 8th in the expansion of x to the 12th, or x squared plus 2 all to the 12th power? Let's think of how this is going to play out. We've got an x squared, right? Okay. It would be taken to the 12th power the first time, wouldn't it? Okay. So we want x squared to the 12 minus r to be equal to x to the 8th. Because when we look at our summation, okay, we have our highest power minus r. We want to figure out what our r is going to be here. Okay. So we need to figure out what r is. And we have an x squared to begin with. Okay. So how do we solve something like that? We multiply our exponents first. Okay, power to a power we multiply. Yeah. When the bases are the same, then the exponents are the same. So 24 minus 2r is equal to 8. Take 24 to the other side. Negative 2r is equal to 8 minus 24. So r is, okay. So we want the coefficient when r is 8 of this guy. So the coefficient right, of, but we have to calculate this 2 in, don't we? This 2? So far, we were only worried about the coefficient of x to the 8th, so we were just looking at this first term to figure out what our value for r is. Okay. So it's going to be in there, absolutely, has to be in there, otherwise our coefficient will be messed up. Okay. So we know we're going to use this combination. Okay. Then x would be to the 12 minus r, right? And then our 2, our positive 2, would be to the r. That's similar to what we're, yeah. Because we're looking, we really wanted to get x to the, we needed the 4th power. We need n to be 4. Okay. So now we work it out. 12 factorial divided by 12 minus 8 times 8 factorial. We'll have x to the 8th and then 2 to the 8th. 2 to the 8th is 256, right? Okay, 12 factorial. You guys have a button on your calculator that you can do this probably quicker than I can. But 12 factorial so whatever 11 times 5 times 9 is 55 times 9 times 256. From the 2 to the 8th. We get a huge number, don't we? Even bigger. This one might be 495. Yes, times 256. The final result is 126,720. And unfortunately, I can't do that in my head. It would be x to the 8th is what our whole goal was. Yeah, yes, it would be, well, this was, thank you. Now I know where someone was saying, where did my x squared go? Yes, that's where your x squared went. My apologies. X squared to the 12 minus 8. It's just our x to the, it's x squared to the 4th. Yeah. Yep. Okay. And you wouldn't have had to, no, not a lot. You wouldn't have had to formally do this. I was using the notation. You could have said, okay, if this is going to be x to the 8th, then n's got to be, or r's got to be 4. Because 8 divided by 2 is 4, so r would be 4. Yeah, absolutely. Okay. You want to see one more? Are you guys okay? You okay? Just want the assignment? Okay. Page 649. 19 to 34 by 3s. 45 to 60 by 3s. Good question.